The first is volume equals capital B, capital H. Okay, capital B represents the area of the base of your solid, and capital H represents the height of the solid. Okay, this volume formula works for two different classifications of solids. It works for prisms, and it works for cylinders. So if you took a prism, so let's say, again, we'll start with what we have in most of the others. If we take this triangular prism, the volume formula that you will use for this solid is capital B, capital H. But what is the specific area formula for this base shape? It's a triangle, so the area formula of a triangle is 1/2 base times height, all times the height of the solid. Okay, so here is what you would wind up using for your volume formula. You don't need to memorize a specific formula for every type of base shape. If you know the general rule, V equals capital B, capital H, you can figure out any other formulas based on whatever shape you have as your base. Okay, so if I gave you something like this, and let's say you had a regular pentagon as your base, and you're dealing with a prism. Your volume formula, would be B times H. Now remember, in each of these, H is the height of the solid. It's the distance between the bases. What is the volume formula going to be for this base shape? A regular pentagon is going to have a volume formula of 1/2 SAN times H. And so for this particular shape, here's what your volume formula would be. And you just calculate it through based on that. All right, let's take a look at this example. And so this is a solid that we used for our surface area. Okay, tell me what would be the total volume of this solid. Okay, see if you can calculate that. You shouldn't need a calculator. I'd strongly encourage you to write out the general formula if you're solving this on paper. It just helps reinforce the steps that you need to follow. And then I'd replace that general formula with the specific formula based on the shape. So here we have a triangle, so it's 1/2 base times height times the height of the solid. Again, this reiterate the reason I use capital H for the height of the solid so that it doesn't get confused with any lowercase h. Capital B represents the base of the solid, so it doesn't get confused with the lowercase b that would be the dimensions of your base shape itself. Okay, once you have your specific formula based on the classification of your solid, you can now plug in the known values. So our base of our triangle is 8. The corresponding height of that triangular base is 12. And the height of the whole solid is 10. And so when you calculate this through, half of 8 is 4. 4 times 12 is 48. 48 times 10 is 480. Okay, volume is a three-dimensional measurement, so even though we don't have units here, we'll just label it U for unknown units. And it's a cubic measure because of the 3 dimensions. Right, coming back to the other formula, or the other figure that this formula works for, and that's a cylinder. A cylinder, all cylinders have base shapes that are circles. They involve a radius and a height. And so the volume formula for a cylinder is just the same thing. Volume is equal to area base times the height of the solid. So this is the formula for both of the solids that have parallel and congruent bases. But you know that the base is always a circle. So the area formula pi r squared times h will always be used for a cylinder. And now, do you need to memorize this specific formula? You shouldn't. You guys should have the area formulas for all the different shapes memorized. And so the rule is just use the area formula for the base times the height of the solid, and that gives you your total volume. And the one other thing that I want to talk about regarding volumes of solids is, if you recall, the ratio of parts of two similar figures is m to n, then the ratio of their areas is that ratio with what applied to it, squared, right? Whatever dimensions are. So area is 2 dimensions, so you take the ratio of their parts and square it to get the new ratio of areas. Well, that's true with solids as well. So if we took a similar solid here, so let's say we took one that was half of each dimension. So a height of 5, the base dimensions of 4 and 6. And I asked you to find what's the ratio of these surface areas. Okay, well, what's the ratio of the parts between these two similar solids here? The ratio of parts is 1, or in this case 2 to 1. So what's the ratio of their areas going to be? 2 squared to 1 squared. So the surface area of this solid is going to be 4 times the surface area of this smaller one. Okay, what do you think is going to happen if we try to correlate their volumes? We take the ratio of their parts, m to n, and we'll do what to it? Volume is a 3-dimensional measurement, so we're going to cube it. And so if I ask you to identify what is the volume of this solid here, what we would do is we could go back to here again. You always have to refer back to the ratio of parts. If the ratio of parts were 2 to 1, then the ratio of their volumes would be 2 cubed, or 8 to 1 cubed. So 8 to 1. And so what we would expect is 1/8 of 480 is going to be the volume of this figure. So if we took 480 and we multiplied it by 1/8, 8 goes into 48 6 times with the 0, so we get 60. So the volume of this smaller solid should be 60 cubic units. Okay, we can calculate it out to verify it. Our area is, we use a calculator just to demonstrate, so 1/2 times 4 times 6, all times 5, and we see that it confirms what we found using the ratio of parts. And so anytime you have a dilation of parts in two similar solids, this ratio of parts, ratio of areas, which for solids is surface area, and ratio of volumes will be maintained. Okay, so be aware of that. Questions on this formula? Volume equals area of base times the height of the solid for prisms and cylinders.